Alright, frame layouts stack their views. Okay, so as we've already seen, linear layouts arrange the views in a single row or column. Each view is allocated its own space on the screen and they don't overlap one another. Sometimes, however, you want your views to overlap. As an example, suppose you want to display an image with some text overlaid on top of it. Okay. You wouldn't be able to achieve this with using a linear layout. If you want a layout whose views can overlap, a simple option is to use a frame layout. Instead of displaying its views in a single row or column, it stacks them on top of each other. This allows you to, for example, display text on top of an image. So how you define a frame layout? Okay, this remains the same. So you define a frame layout using frame layout element like this. Just like a linear layout, the Android layout width and height attributes are mandatory to specify the layout's width and height. Okay. So we will create a new project. Okay, so we will create a new project. New project. Let's call it duck first. Okay, there is another app already here. Okay. Skip. Yes. All right. So. Two. Okay. Yeah. So we have. Okay. Let's finish this. We can get rid. New project cannot create. Two. New project was only partially completed. Your project may not compile. You may want to undo to get back to the original state. Okay. New module failed. New module was. Okay. I don't know what happened. Duck. Okay, create a new project. To see how frame layouts work, we're going to use one to overlay text on an image. Create a new Android Studio project for an application named Duck with a company named Shway.com, making the same name. Thus, the minimum SDK should be 19 so that it will work on most devices. You'll need an empty activity called main activity with a layout called so code matches ours. Okay, add add an image to your project. All right. So we're going to use an image called duck.jpg in our layout. So we need to add it to our project. To do this, you first need to create. Okay, so is this done? No app. Where is my app? My man. Okay, we open it again. Okay, so we're going to use an image called duck.jpg in a layout. I hope. To do this, you first need to create a drawable resource folder. If Android Studio hasn't already created for you, this is the default folder for storing images in your resource app. Okay. Switch to project view of Android Studio Explorer and select app source main res folder. To go to the file menu, choose a new option. Create new Android resource directory. Okay, So it is indexing. App. Should we create a new project entirely? I think so. Okay. So go to the file menu. This when prompted, drawable, name the drawable thing. Okay. Once you've created drawable folder, download the file duck.jpg from here and add it to the source. Okay. Not found. Okay. Okay. I'm going to change activity underscore main.xml so that it uses a frame layout containing an image view. Nothing in the app. Okay. Let me just fix this real quick. What should it be? Chapter 5.2. Good. Alright. Everything's great. Yeah, okay, great. Okay, so then add it to this folder. Okay, we're going to change activity main.xml so that it uses a frame layout containing an image view, a view that displays an image, and a text view. Okay, to do this, replace the code in here. Okay. Tools context. Okay, image view, drawable at duck. Okay, it's a duck. This crops the image's edges so that it fits in the available space. Okay. Alright, so let's download. Duck. Rubber duck. How's this duck? Yeah. There we go. Uh, does it have view image? Can I save image as? Okay. WebP. Oh shit. WebP. JPEG. Yes, there we go. Okay. So I'll go to this folder. I'll go to app source main res drawable. And I'll go duck.jpg. Okay. Right, so I have okay, running drawable duck.jpg. Okay. Should I have not? Okay, so project external libraries duck source main res drawable. Maybe I can rename it duck factor. Okay, alright, so we're all good. Okay, so first thing is the thing is we are going to use a frame layout. And then first we provide the namespace. HTTP schemas .android.com -apk/res android. Okay, then we provide the tools, right? XMLNS tools, HTTP schemas .android.com/tools. Then we provide the Android layout width equals match parent. Android layout height equals match parent. Cannot resolve frame layout. My bad, bro. My bad. Yeah. Okay. So we have still something wrong. Okay. Android schemas tool. Okay. Android layout width. Okay. It says wrap content on the height. Okay. You have wrap content, and then I think it is tools context equals dot main activity. Okay. Or I could also write com dot example dot duck dot main activity. Okay. Then we first will add an image view. Right, okay, we're using a frame layout. That's up. Okay, this adds an image. image view. This adds an image to the frame layout. You'll find out more about image views later in the chapter. Okay, well, very well. Okay, scale type. This crops the images. This crops the image's edges so that it fits in the available space. Okay. This line tells Android to use the image named duck located in the drawable folder. Okay, we can do that. Nice. Okay, this adds a text view to the layout. You increase the size of the text 20 sp. In a real world duck app, you would want to add this text as a string. Okay, so I'm going to add an image view. This will define Android layout width equals, we have match parent, and then Android layout height is wrap content. Okay, then we say scale type. Okay, and we provide a source. Android scale type equals center crop. And Android source is @drawable / duck. Okay, so this is our image source. Then we provide a text view and okay. Okay, so Android layout width because I think it's both wrap content. Yeah, wrap content. Android layout height is wrap content, and then we provide a little padding and text size. Okay. So Android layout padding, only padding for 16 dp, and then we set the text size equals to 20 sp and paddant, yeah, okay, padding, and then we provide the text equals, it's a duck, yeah. Alright, there we go. Okay, then run your app and we'll look at what the code does on the next page. Okay, a frame layout stacks views in the order they appear in the layout XML. Okay. When you define a frame layout, you add views to the layout in the order in which you want them to be stacked. The first view is displayed first, the second is stacked on top of it, and so on. Okay. So in our case, we've added an image. In our case, we've added an image view followed by a text view, so the text view appears on top of the image view. Okay. Position views in the layout using layout gravity. Okay. Position views in the layout using layout gravity. Okay, so we okay, by default any view you add to the frame appears in the top left corner. You can change the position of these views using the Android layout gravity attribute, just as you could with a linear layout. Okay, examples, bottom end. Okay, so I can update that. We can say Android layout, Android layout gravity equals bottom and end. So it will appear in the left right corner. There we go. Okay. You can nest layouts. Okay, one of the disadvantages of using a frame layout that it's easy for views to overlap one another and you don't want them to. As an example, you may want to display two text views in the bottom end corner, one above the other. Okay, if you're not careful, the views can overlap one another like this. Okay. It's possible to solve this problem by adding margins or paddings to the text view. A neater solution is, however, to add them to a linear layout, which you then nest inside the frame layout. Okay. Doing this allows you to arrange the two text views linearly, then position them as a group in frame layout. Okay. So here's the frame layout, contains the image and a linear layout, and this is the linear layout. It contains two text views neatly arranged in a single column. I'll show you the full code for how to do this on the next page. Okay, so we create this, then we have a linear layout, and we set its gravity to the bottom end, and then we write them the same. Okay, so we're just adding a linear layout. Okay, so we're adding a linear layout that's just as big enough to contain the text views. Okay, then we have, okay, so gravity layout, we shift the whole linear layout to the bottom end. This line syncs the linear layout to the bottom end corner of the frame layout. Move each text view in the linear layout to the end of its available space. Okay, so we add these linear layouts here. Okay, so first I'll create a linear layout. We have wrap content. We have wrap content. Android layout. Okay, Android layout gravity is bottom end, and then Android gravity, like the text within it, should be on the end. Then we say Android orientation is vertical, and linear layout. I can add these text views in here, and then I don't have to care about the gravity, right? I just have to text size is this. Don't care about padding. Do we care about padding? I don't think so. Yeah, okay. We care about padding, and then I can make another one that says not a real one. Okay, so this looks right. Okay, frame layout, a summary. Okay, here's a layout. Here's a summary of how you create frame layouts. How you specify frame layout? You specify frame layout using frame layout. Okay, you must specify the layout width and height. Views are stacked in order they appear. When you define a frame layout, you add views to the layout in the order in which you want them to be stacked. The first view you add is displayed on bottom of the stack. The next view is stacked on top of it. Okay. Use layout gravity to specify where a view appears. Okay, the Android layout gravity attribute lets you specify where you want a view in the frame layout to appear. You can use it to push a view to the end, for instance, or sink it to the bottom corner. Okay, then we have, now that you've seen how to use simple Android layouts, the linear layout and frame layout, have a go at the following exercise. Okay, be the layout. 3 of the 5 screens below are made from layouts on the next page. Your job is to match each of the 3 layouts to the screen that the layout would produce. Okay, so let's see. We have first, we only have a button that says hello. Layout width and height is match parent, a whole screen of hello. This this is A. Then we have match parent. Okay, so this is layout weight is 1. Button, and then we have hello and hi. So hello is bigger and hi is just in the left corner. There we go. This is B, and we have C. Okay, linear layout. So we have button. Okay, match parent vertical. We have a hello and a hi, and this is linear layout. So hello and hi to the left side. There we go. This is C. Okay, so we have first one is A. Okay, layouts and GI components have a lot in common. Okay. I got them right. Okay. Yeah, right. Okay. So this is the first one. So it's the screen underneath. Layouts and GI components have a lot in common. You may have noticed that all layout types have attributes in common. Whichever type of layout you use, you must specify the layout's width and height using Android layout width and Android layout height. Okay. Using the Android layout width and height, okay, attributes, and this requirement isn't just limited to layouts. The Android layout width and Android layout height are mandatory for all GUI components too. This is because all layouts and GUI components are subclasses of Android View class. Okay. GUI components are a type of view. You've already seen that GUI components are all types of views. Behind the scenes, they are all subclasses of the Android.view.view class. This means that all of the GUI This means that all of the GUI components in your user interface have attributes and behavior in common. They can all be displayed on the screen, for instance, and you get to say how tall or wide they should be. Each of the GUI components you use in your user interface takes this basic functionality and extends it. Alright. Then we have Android, which takes you the direct subclass of. Okay. We have Android View is the base class of all GUI components used to develop your apps. Okay. View is a direct subclass. Okay. Spinner is the type of view that you saw in chapter. We'll revisit it later in the chapter. Okay. We have edit text button. So layouts are a type of view called a view group. Okay, it's not the GUI component that are a type of view. Under the hood, a layout is a special type of view called view group. All are subclasses of the Android.view.view class. A view group is a type of view that contains another group, another view. A GUI component is a type of view, an object that takes up space on the screen. A layout is a type of view which is a special type of view that contains other views. Right, okay. So layouts are a type of view group. View group is a subclass of view. Okay. Then we have what being a view buys you. A view object occupies rectangular space on the screen. It includes the functionality all views need in order to lead a happy, helpful life in Android well. Here are some of the qualities of views that we think are the most important. Okay. So getting and setting properties. Each view is a Java object behind the scene. That means you can get and set properties in your activity code. As an example, you can retrieve the value selected in a spinner. Okay, as an example, you can retrieve the value selected in a spinner or change the text in a text view. The exact properties and methods you can access depends on the type of view. Okay, getting and setting properties. To help you get and set properties, each view can have an ID associated with it so that you can refer to it in your code. Okay, here are some of the view methods you can use in activity code. As they are in the base view classes, they are common to all. Okay, size and position. You can specify the width and height of views so that Android knows how big they need to be. You can also say whether any padding is needed around the view. You can specify the height and width and height of views so that Android knows how big they need to be. You can also say whether any padding is needed around the view. Okay. Once the view has been displayed, you can retrieve the position of the view and its actual size on the screen. Focus handling. Android handles how the focus moves depending on what the user does. This includes responding to any views that are hidden, removed, or made visible. Okay. And we have event handling and listeners. Views can respond to events. You can also create listeners so that your app can react to things happening in the view. An example, all views. Okay. As an example, all views can react to getting or losing the focus and a button, and all of its subclasses can react to being clicked. Right. Okay, so these are the that's now the comments. So get ID, get height, get width, set visibility, find view by ID, and we have um, if clickable is focused request. Alright, nice. Okay, so as a view group is also a type of view. This means that all layouts and GUI components share this common functionality. So a layout is really a hierarchy of views. The layout you define using XML gives you a hierarchical tree of views and view group. As an example, here's a layout. Here's a linear layout containing a button and an editable text field. The linear layout is a view group, and the button and text field are both views. The view group is a view's parent, and the views are the view group's children. Right. Okay. So this is button. Okay. So the linear layout and this. Okay. So behind the scenes when you build your app, the layout XML is converted to a view group object containing a tree of views. In the example above, the button gets translated to a button object, and the text view gets translated to a text view object. Button and text view are both subclasses of view. Okay. This is the reason why you can manipulate the views in a layout using Java code. Behind the scenes, all of the views are rendered to Java view objects. Okay. So playing with views. Let's look at the most common GUI components. You've already seen some of these, but we'll review them anyway. We won't show you the whole API for each of these, just the highlights to get you started. Okay, text view. A text view is used for displaying text. You define view in a layout using text view element, and your text to say what text you want to display. Usually bring it usually by using a string input. Okay, so the text view API includes many attributes to control the text view's appearance, such as text size. To change the text size, use the Android text size attribute. Okay, to specify the text size using scale independent pixels take into account whether user wants to use large font on their device. A text of 16 SP will be physically larger on a device configured to use larger font than on a device configured to use smaller font. Okay. So using it in activity code, we have text view and then this. Okay, editable text view, defining it in XML, we use this. I'm going to show you the hint. Right. And the text view. You can use the Android input type attribute to define the type of data you're expecting the user to enter so that Android can help them. As an example, if you're expecting, it can help them. Okay, so we have these values. Okay, as an example, if you want numbers, you can add a number. Text password, automatically correct the text being input. Text cap sentences, capitalize the first word of the sentence. Okay. You can find the entire list in the online Android developer documentation text view. Okay. So you can specify multiple input types using the pipe character. As an example, the spelling grid use. Okay. Nice. Okay, using it in your activity code, you can retrieve the text entered in an editable text view like this. And view by ID, get text to string. And we have a button. Alright. So buttons are usually used to make your app do something when they're clicked. Defining it in XML, button use. So you want to display. You have Android text string button. Okay, using it in activity code. You get the button to respond to the user clicking it by using the Android onClick attribute in the layout XML and setting it to the name of the method you want to call in your activity code. You then define the method in your activity like this. Called when button is clicked, public void button view. Okay, toggle buttons. Okay, so we haven't reached toggle buttons, right? Okay, so toggle button. A toggle button allows you to choose between two states by clicking a button. Okay, this is what toggles button looks when it's off, and this is what it looks when it's on. Okay, you define a toggle button in XML using toggle button element. You use the Android text on and Android text off attributes to say what text you want the button to display. Using it in your activity code. Okay, so toggle button. This is text on and off. Using it in your activity code, you can get the toggle button to respond. You can get the toggle button to respond to the user clicking it by the Android onClick attribute in the layout XML. You give it the name of the method you want to call in your activity code. Okay. This is exactly the same as method of a normal code. Okay. When you define the method, when you define the method in activity like this, okay, this returns if the button is off or on. Okay, if checked. Okay, then we have a switch. A switch is a slider control that acts in the same way as a toggle button. Okay, this is when the switch is off. This is when the switch is on. Defining it in XML, you define a switch XML in XML using switch element. You use the text on and text off. Okay, so this is the switch. Okay, using it in activity code, you get the switch to respond to the user clicking it by using the Android onClick attribute in the layout XML and setting it to the name of the method you want to call in your activity code. Okay. When you define the method in activity like this, okay, onClick, same. Okay, then we have checkboxes. Okay, checkboxes lets you display multiple options to users. They can then select whichever option they want. Each of the checkboxes can be checked or unchecked independently of any other. Okay. Here we have two checkboxes. User can choose milk, sugar, both milk, sugar, or neither. Okay. Defining them in XML, you can define each of the checkbox element with the Android text attribute to display text for each of the option. You can define each checkbox in XML using checkbox element and Android option, Android layout. Using the mini activity code, you can find whether a particular checkbox is checked using the isChecked method. It returns true if the checkbox is checked. Okay. Checkboxes, just like buttons, you can respond to the user clicking a checkbox by using the Android onClick attribute in the layout. Okay, so Android onClick, Android onClick. In this case, the on checkbox clicked method gets called no matter which checkbox gets clicked. We could have specified a different method for each checkbox if we have wanted to. Okay, so you can then define the method in activity like this: rid dot checkbox milk. Okay, if checked. Okay, then we have radio buttons. These lets you display multiple options to the user. The user can select a single option. Okay. Use radio buttons to restrict the user's choice to use one option. Okay. Defining them in XML. Okay. You can choose a radio group tag and then define a single radio button. You can choose a display radio button in a horizontal or vertical list. Okay, using them in your activity code, you can find which radio button is selected using get checked radio button ID. So this is a single. Okay. You can respond to the user clicking a radio button by using the Android onClick attribute in the layout XML and setting it to the name of the method you want to call in your activity code. Okay. So radio group containing the radio buttons is a subclass of linear layout. You can use the same attributes with the radio group as you can with the linear layout. Okay. So we have you then define the method in your activity like this. Okay. So id given attribute. Okay. So we get radio, then we check whichever is checked. Okay, then we move on to spinner. Okay, as we've already seen. Okay. As we've already seen, a spinner gives you a drop-down list of values from which only one can be selected. So we saw spinner. Okay. An adapter view is a view that can use an adapter. You'll find out about adapters later in the book. Okay, this is an abstract base class for spinner widget. Okay. Okay, so defining it in XML. Okay. There are other ways of populating the spinner which we'll see. Okay, so you define a spinner XML using the spinner element. You add a static array of entries to the spinner by using a Android entries attribute and setting it to any of the arrays of string. Okay. Array, right. You can add an array of string XML like this. Using it in your activity code, you can get the value of the currently selected item by using the get selected item method and converting it to a string. Okay, you can get the value of the currently selected item by using the get selected item method and converting it to a string. Okay. Then we have image view. Add an image view contains an image. The image view class is a direct subclass of view. Okay. Okay, an image view. Adding an image to your project. You first need to create a drawable resource folder, the default folder for storing image resources in your app. To do this, okay, file menu. Okay, if you want, you can use different image files depending on the screen density of the device. This means you can display higher resolution images on higher density screens and lower resolution on lower density screens. To do this, you can create different drawable apps. Okay, depending on the screen densities. Okay, low density. Okay, depending on what version of Android Studio is running, the IDE may create some of these folders for you automatically. Okay, you then put different resolution images in each of the drawable folders, making sure that each of the image files has the same name. Android decides which image to use at runtime, depending on the screen density of the device it's running on. Okay. An example, if the device has an extra high density screen, it will use the image located in the drawable XHD DPI folder. Okay. If an image is added to one of the folders, Android will use the same image file for all devices. Just one of the folder. Okay. If you want the app to use the same image regardless of the screen density, you'd normally put it in the drawable folder. Okay, then we have image view, the layout XML. Okay. You define an image view in XML using image view element. You use the Android source attribute to specify what image you want to display and Android content description attribute to add a string description of the image so that your app is more accessible. Okay. The Android source attributes could take a value from @drawable image name, where image name is the name of the image without its extension. Image resources are prefixed with @drawable, which tells Android that it's an image resource located in one or more of the drawable folders. Okay. So using image views in an activity code, you can set the image source and description in your activity code using the image set image resource and set content description. This code looks for the image resource called Starbuzz logo in the drawable folder and sets it as a source of the image view with an ID of photo. When you need to refer to an image resource in activity code, use the r.drawable image. Okay, without its extension. Adding images to buttons. Oh, bro, how much more? Scroll view. Toast. And then that is all. I hope, is that all? Yeah. Okay. Okay, I think this is enough for today. Let's try and run this. See how it looks. Okay. Adding images to buttons. In addition to displaying images and image views, you can also display images on button. Displaying text displaying text and image on a button. Okay. So to display text on a button with an image to the right of it, use the Android drawable right attribute to specify the image to be used. Okay, displays the Android image resource on the right side of the button. You can also use drawable start and drawable end to support right to left languages. Okay. So RID dot dude, why do we have so many things? Let's get rid of this. Edge to edge. Import android.app.activity, and we just want activity. Okay. Okay, so drawable. Okay, if you want the Android to display the image on the left attribute, use this. Use the Android drawable bottom attribute to display image underneath the text. Okay, and top for on the top of the text. Okay. You have image button. An image button is just like a button except it contains image and no text. Okay. Defining it in XML, we provide the source. You define the button. Use the Android source attribute to say what image you want the image button to display. Right, like this. Still using it in activity code, you get the image. Okay, you get the image button to respond to the user clicking it by using the Android on click attribute in the layout XML and setting it to the name of the method we want. Yeah, cool. Okay, the image button class extends the image view class, not the button class. Okay, so we have, then we define the function like this. Okay, then we have scroll view. Okay, if you add lots of views in a layout, so maybe I have a problem in a device with smaller screens. Most layouts don't come with scroll bars that allows you to scroll down the page. As an example, when we've added several large buttons to linear layout, we couldn't see all of them. Okay. To add a vertical scroll bar to a layout, you surround your existing layout with a scroll bar element like this. Scroll bar view element. Okay, move these attributes from original layout to scroll view is the root element. Okay, so horizontal scroll. Okay. To add a horizontal scroll bar to your layout, wrap your existing layout inside a horizontal scroll view element instead. Okay. Wrapping your layouts in a scroll view has added a neat vertical scroll bar. User can now get to all of the views. Okay, then we have a toast Okay, there's one final widget we want to show you in this chapter, a toast. A toast is a simple pop-up message you can display on the screen. Toasts are purely informative, as the user can't interact with them while a toast is displayed. The activity stays visible and interactive, but the toast automatically disappears when it times out. Okay. A toast isn't actually a type of view, it's a useful way. It's a useful way of displaying a short message to the user. So we're sneaking it into this chapter. Okay. Okay, so you create a toast using activity code only. You can't define one in your layout. To create a toast, we call it toast dot make text method and pass it three parameters: context, usually this for current activity, a char sequence, that's a message you want to display, and int duration. Once you've created the toast, you call the show. Here's the code you would use to create a toast that appears on screen for a short duration. By default, the toast appears at the bottom of the screen.